Okay, in the previous session, we were discussing about creating variables and then did typecasting, converting from one type to the other type. Particularly, we have seen how numbers are typecasted, and then we went to type conversion, converting from rune to string and string to rune, and then converting from bool to string, string to bool, and all these things we have seen in previous examples. Today, the mkdir variables, five variables, go mod init demo. I'm going to explain something about a special data type, which is called any type in Golang. Any type is very special data type. It's very much used as well. It's used everywhere in Go with the uh, adding this particular interface, generics in Go, I think uh, the use of any has come down a little bit, but still any has to be used everywhere, you know. Okay, what is any? Any is pretty different data type. We also call it as an empty interface. Empty interface. Okay, we call it as, which is denoted like this. Before version 1.18, it was only called as empty interface, but from 1.18 onwards, a alias has been created for an empty interface, because empty interface, the name is maybe not sounding very well. Uh, it doesn't really make sense to every time call empty interface, so it was renamed as, it's just an alias was created as any. You know that how to create an alias, then you can simply go and then put type any equal to empty interface. This is what they have done in built-in library. Then 1.18 onwards, everyone talks about only any. People seldom talk about empty interface. We don't see. But old Go guys like me and who have been using Go for some time, a few years, they know that it was called as an empty interface. So if I say any or empty interface, right now I say only any. But whether if I say empty interface or any, I mean to say that both of them are same. Okay, I mean to say that both of them are same. Any is a type that can store any kind of uh, data type. Ultimately, if you are seeing any is there to store any kind of database data type. That means you know that object in Java, object in C sharp and all. It's very famous. What object in Java and then what object in C sharp does? Object in Java and then C sharp is used to store any kind of object. Basically, object in Java or object in C sharp is used to store any kind of object. Any kind of object means any kind of data, basically object in C sharp. Any kind of data can be stored in C sharp or Java. Similarly, you can create a variable, something like where any1 is, earlier it was like this. Okay, but as I said earlier, there is an alias. You don't need to create, it was already created, which is called where, let it be a simple x as any. What does it mean? X is a variable. X can hold any kind of data, any type. Yes, X can hold any type. Basically, that's what X. If you write this also same, where X of empty interface is also same. X can hold any data. At runtime also you can change the data. That is the most important thing. Okay, let's see. X equal to hello world. Okay, I can go on print line X. Print line is a built-in function. As you see, there are keywords and there are built-in functions. Okay, you can go to keyword section. We were writing somewhere keywords, I guess. Where are we writing? Okay, nowhere you are writing. I will write a new file called keywords notes. I just put as notes.md. There were some keywords. If you look keywords in Go, so far, what are keywords we have been using? We have been using uh, package first, and then import, function, var, const. These are all keywords that we have been using so far. These are all the keywords we have been using. We used type as well. Type is also a keyword, but just use a type for uh, aliasing. But there is a much more use of a type. Later on, we will discuss about it. And then I would also like to say print line type of x is reflect or type of x. Okay, go run. Unfortunately, print line is not a friendly print line. It can store the values, but wherever it could see some kind of a reference, fmt dot. I'll tell you why it is print line and fmt dot print line wherever go run. Okay, you see that hello world has been printed, and then whenever you see that type of x, then it's reflect dot type of x has been given as string, but the data type is not string, which is any basically. It's very important data type in Go. Let's see the another one. Let's say I use the same x equal to true. Then you print, and then you give the value x as some value, print, and then you give the x value, you print. You see that the same x, we are using same x. It's not a shadowing or anything. I'm not creating one x in one scope and other x in other scope. Everything is in the same scope. The scope is same. There is an x, and then I am giving x as string, and then I'm giving x as boolean, x as integer, x as float 64. By default, it takes as 64 and all. You see that. Let's say in another way, sorry, not let, where num equal to u int age equal to some number, then x equal to num, and then we got to print x. These many things we are doing here. X is any, but for x, any kind of type, any type we can give to x, any type we can give to x. Ultimately, that's what we are using. Uh, why do we use? What are the use cases of this? If you really look at it, what are the use cases of this? There are use cases. Okay, what are the use cases of this? Why do you use any? Number one, you don't know what is the data that is coming, what type of data that is coming. Let's say that the type of data that is coming is decided at runtime. Maybe the data is coming from a web service, which is from another application. You don't have any idea that what kind of data that is coming into your system. We can create any, generally generic data structure. Generic data structure. We can use generic data structures. We can use any. And the second thing is dynamic type handling. Dynamically at runtime, dynamically you handle the type of type of the data, that is type of the variable or type of the data that is inside a variable. Then you can also use any. Okay, there are few use cases for any. This is one of the use case. Type of the data, One is called dynamically data is coming. Number one is called dynamically data is coming. That is something. Dynamic structures, generic, sorry, generic data structure. We don't have, Go did not have a generic concept before the version 1.18. As I said earlier, Go didn't have data structures concept before the version 1.18. Okay, Go has got data structures only from 1.18 version. So whenever you want to create a generic implementation, I will show you later on how to create a generic implementation and all, but whenever you have to create a generic implementation, one of the ways we used to do was using any. Any was used everywhere in Go to implement generic implementation. You know that what generics are. You want to perform an addition operation. If you want to do it for integers, you have to create one function. If you want to do it for float, you may have to create one function. But by using generics, by creating a single function, by implementing generics concept, you can use the function for different types. Uh, Again, there are some pros and cons. There are some certain things are viable, certain things are not, certain things are feasible, certain things are not. For example, you have to perform an arithmetic operation. Yeah, arithmetic operations can be performed only on numbers. Okay, you cannot bring data type something called boolean and then say that perform an arithmetic operation on boolean. It's not possible, but logical operations on boolean is possible. So it depends on, actually you should have some sense what kind of operations that we are trying to perform on a particular type. Okay, that's where actually usually we use uh, implementations, these kind of implementations. You see that we have created any and then we can give any type of data. When I run it, you understand any is capable of storing any kind of value and then you can print. It's a string, it's a bool, it's a int, it's a float 64, it's a uint 8 because we directly assigned the value from uint 8. We directly assigned a value from uint 8 to here to x, so it is uint 8. So any type can be given to any other type. Let's say that I create another type. Sorry, where y is any. Let's first change. I put an interface equal to x. See that. So now is y is empty interface and x is also empty interface. Then I would like to print the value of y and type of y. I print the value of y and then type of y. I like to print. You see that the type of y is not empty interface because as soon as a type is given, because what is the type of x here? It is not any here. Technically, it is not any here. We may see that it is any because x is any, but technically as soon as a value is assigned to x, the type of x, you see that the type of x has become uint 8. Type of x is not showing it as any. So any is not a type itself, but any can hold any type. That is what the technically any is. And one more thing is, if you create any and then don't give any value, where z is any, but I don't give any value. No, when you print any, z is any, but I don't give any value to z. If you print any, there is in one of the examples I told something called nil. We will see that first. The type of the value inside any is nil and the type of any is also nil. That means any doesn't hold any type. Any can hold any type. The concept of any is any can hold any type, but any doesn't carry a value like type inference of any other variable. Let's say if you create a integer variable, automatically it has got a value inference which is called 0. If you create a boolean variable, it has got a value inference as false. If you create a string, then it has got a value inference as empty string. If you don't give assign any value, there is an value inference. It doesn't go and bring the garbage of these values. Definitely there is a value inference. But for any, by default, if you don't assign any value to any or any other variable to any, it holds the value is nil. Nil. There is no null in Golang. There is only nil in Golang. It's everywhere. We call it as nil. There is only nil in Golang. And the type of any is also nil. Remember that it's not only the value, it's also a type. It's very, very important. The reason is if the type later on we will come across some scenarios where type of any is very, very important. I will talk about it. Type of any is very, very important. Okay. There is something called type switch for any. There is certainly there is something called type switch for any. The type switch is very, very important for any. Okay, fine, we will discuss about it later on. Cool. Right, what I'll do is I don't try to uh, disturb this example, but I would like to create another example. I would like to move from 5 variables to 5 any. 6 also, let it be any. So 6 any, go mod init demo, code main.go. Now, yeah, we are here. Package main, because I keep on writing the code rather than copying pasting somewhere, because for me also I work on multiple languages. I keep on switching between Rust and I work on rotation. Sometimes I work on Rust. That's why you can see that let is coming automatically, because the Rust syntax is that I work on rotation, sometimes on Rust, sometimes on Go. That's the reason. Uh, Sometimes I get the Rust syntax. Fine. There's a reason for the practice. I try to write everything by myself. If I don't find proper syntax, I go and search online. That's what I do, like anyone else. So let's say again, variable x is any equal to 100. That is some value, some random value. In fact, you can also rand function. There is a package called math.rand, rand dot automatically math.rand int n with the range of some number. Okay, that means a random number is created within this particular range and assigned to x. That means it's gonna return the import. It's kind of math.rand is the package. Okay, it is going to return integer. Int n returns as an int a non-negative pseudo random number in the half of an interval from 0 to n from the default source. It panics if n is less than or equal to 0. Whenever then this value you pass, this value you pass. If it is less than 0, that means you put minus 100. It panics. Panics is kind of an error you come across. That means go run off this, then it is a panic. Sorry, I have not printed x, so it's a compile error. Let me fmt dot print line of x just now and then go run this. It's gonna be a panic. Panic is nothing but a runtime error. It's not always a runtime error. It's a panic. There is some problem. Either it could be due to runtime or even you can also create your own panics. Panic is a kind of an error. Okay, but panic crashes your application unless it is maintained. Okay, so you should not give random number, my negative number. You can ask me a question. Then why should it be an integer? They would have given as uint instead of giving n as int. they would have given n as uint. Of course, yes, that is true. But I don't know why they have given n as int. They would have given n as uint, so that even there is no need to even panic. It should not. It doesn't allow even the negative numbers. However, fine. Rand.int is from a package called math. Inside math, there is a sub package called rand. From rand, there are so many functions. Which one of the functions is called rand int? That means it generates a random number. If you put a loop, it generates those many. Based on the loop, it generates those many random numbers. I would like to utilize this particular concept to create a random number, to show that you can also create a random number. That's the reason I gave this. Cool. Now I want to perform uh, where y equal to some number, where z equal to some number, z. So I want to put as sum equal to x plus y plus z. What is the mistake in this particular scenario? So conceptually, x is not integer, x is any, but x is holding an integer. X is any, but x is holding an integer. Remember that x is not integer, x is any, but any is holding an integer. Okay, when x is holding an integer, you cannot use typecast on any. That means you cannot go and do int of x. Usually we do that. Usually we do that. We cannot do typecasting on this. Rather, what we do is we do type assertion. Type assertion is type assertion. There is something called type assertion. This type assertion is very important, and then type assertion can be done only on, it should be done only for any or empty interface, whatever. Type, this is typecasting, you know that. We already saw typecasting, converting from one type to the other type. But whenever any is involved, we do type assertion. So how do you do type assertion? If you know that, if you know that the type that x is holding is int, how do you know? If you know right now, how do we know? I will tell you. I will show you how we can know. But right now I know that I gave a value called int, so I can type assert it. How can you do type assertion? Type assertion is always any dot type. This is what type assertion is. Any is a variable dot type. Whatever the type you would like to assert. You cannot go and assert. For example, here it is an integer. You cannot go and assert something else. You have to assert only integer. So what I do is here x dot int. This is what the type assertion. Okay, you have to do type assertion only for type assertion is only for empty interface or any. For other type casting, have to use typecasting as usual, but only for any you have to use type. This is called type assertion. So I got to print So what I do, because this is integer and then this is also integer, there is no problem. I can go and then print. If I can directly print, use print line, sum equal to sum, it got to print the sum. So now what happened? Go run dot, it has printed the sum. Fine. Now what I do is I create another variable here, xyz, let it be where I as int 8, uint, let it be 32, equal to uint 32 of y. See that step by step process. First we have created any, we have done type assertion. Now we have to add I as well to this particular calculation. But I is what type? I is of type uint32. I have converted y to, I have casted y, the value of y to uint32 and assigned it. So y is still int, but y is uint32. So how can you convert it? Because you are performing an arithmetic operation, and then you know that for arithmetic operation all the types must be same. You cannot perform arithmetic operations on different types unless they are properly typecasted or type asserted, whatever it is. You cannot perform arithmetic operations on different types. You know that general arithmetic operations, we are not doing any complicated arithmetic operations. A simple addition, which is a pretty simple arithmetic operation. Now what happened, this I is uint32, so I have to typecast I to int. Like this you can use. So one variable is type asserted, one variable x is any, so you have done type assertion. Int I, which is of integer, which is of uint32, so you have done type casting. Let's say I create y, where y, sorry, I already created y, right? X1 as any equal to some value. You see that x and x1 are both belongs to the same type. Here it is int and here it's also it is int. Now then I do sum1 equal to x plus x1. Sum1 is x plus x1. So you see that x and x1 are of actually of both same type. Okay, but you cannot perform any kind of arithmetic operation on a type called any. Any is purely, remember that whenever you are using any, the only purpose of any is to hold any kind of data in scenarios where which we discussed earlier. Any, the purpose of any is only to hold data and type. Any give you what type the data is, any give you the data, but any is not, you cannot be used directly to perform any kind of arithmetic operations. You cannot perform arithmetic operations on a variable type called any. So what you have to do, you must typecast any in order to perform any kind of operation, type assert any in order to perform any kind of operation. So what I have to do, int, and what I have to do, int, because both of them are any, so both of them I have to perform the type assertion. Should be very clear about it. So question number one, what is any? Any is also another name of any is called an empty interface. What is used? It can use it to represent any type of data, any type, basically any type means, yeah, which holds the data. Okay, generally what happened is an interface, if you really, why it is called as an empty interface is Generally, an interface is something that generally, if you look at any interface concept, interface is something that that has got some methods to implement, right? If you go for interface concept or protocols or traits or different languages have different things. Generally in Clojure and all, it is called as a protocol. In Rust, it's called as a trait. In C Sharp, Java, and Go, and some programming language, it's called as an interface. Interface means it must implement some methods, but empty interface means it doesn't have any methods. Generally, since it doesn't have any methods, any type is satisfied, because what what variable or what type that implements an interface, then there is something else in Go. Unlike other programming languages, you don't need to tell Go that I am going to implement this interface. I have a type, I'm a class A that is extending or implementing that is implementing an interface called I1. You don't need to tell that. If class A, there is no classes in Go, for example, I'm telling, if a type doesn't have an interface, if a type does implement an interface, it doesn't need to tell that it is implementing an interface. It is automatically considered if it implements. If the method names are different or method names are wrongly written and all, it doesn't implement. But if a type has to implement an interface, it doesn't need to explicitly tell that, hey, I am a type, I'm a type maybe called person, I am implementing an interface called reader. It doesn't need to say that it is implementing an interface called reader. If it implements, that means a method called read, it automatically considered as it has implemented the interface called reader. Similarly, any type can implement empty interface, because empty interface doesn't contain any kind of methods. That's what many kind of functions or methods or definitions. That's why some people ask why any are called as empty interface initially, because it is purposely named as empty interface to say that it's an interface, but it doesn't implement if with no methods. If there are no methods, the interface has got any type. Technically, any type should implement that particular interface. Fine. This is called type assertion. Okay, fine. How do you know that? How do you know that it has whether the type has integer or not? Let's say, let's say I create another empty interface where x2 is any which contains a number. You see that. What is the type here? The type here is float 64 basically. Now I want to convert a type. Let's say that I have where, okay, maybe num1 is int equal to x2 dot int. You see that what I'm trying to do is, let me use normal print line. If num1, you can also give num1 is num1, print line num. So what I did, x2 x2 is nothing but a float value, but I'm forcefully type asserting it to int, which is not possible. The reason is the type that x2 holds is not int, so you cannot go and then type assert it to int. It gives you a runtime error. It's like uh, it's like that. It's like keeping you have a box for your laptop and then a box for your dresses. You have a bag for a laptop and then box for a dress, but you would like to keep the laptop in the dress box and then uh, uh, dresses in your laptop bag. That means two different things you are trying to assert it that no, I have the value as int, so convert it to int. Technically, what you can do is accept it that float 64 and then convert it to int. This is fine. This is fine, but still, where num1 of int equal to x2 dot int. It looks okay because the compiler doesn't know. Compiler doesn't never gives an error. If you go and then go build, it compiles, so it doesn't give any error here. But because any is something that holds a value at runtime, but the moment you start running your application, it gives an error, which is called a runtime error or panic. Panic. You see that interface conversion. Interface is float 64, not int, but you're trying to convert it as you're trying to assert it as int. So how do you know at runtime? How do you know at runtime that whether the value is int or not? You would like to check whether the value is int or not. A simple check. In order to do a simple check, you must know if else conditions first of all. What actually this does is num1 comma actually this statement, this expression, I don't know whether it's an expression it's trying to convert, which is called x2 dot int. It returns not only one variable, it returns two variables. It returns two variables. It doesn't return one variable, it returns two variables. The first variable is the asserted value, and the second variable is boolean, which is called true or false. You know that this kind of syntax comes in many areas in Go. This is first a sample. This kind of syntax you come across in many areas in Go. Okay, just to keep it aside, you can always check, you can always write if else conditions in Go. So how do you write if else conditions? Still we have to learn if else conditions later on, but here we are here about any and all. Just to have a look at how do you write if else condition. If the condition goes here, condition goes here, okay, if ok1 ok1 equal to true, if ok1 equal to true, that means yes, it is int, it is int. What does it mean? If it is true means it is saying that it is int. Yes, it is int. If ok1 equal to true, actually you don't need to give this. Instead of that you can just put if ok1. This is also enough. The reason is the boolean statements. What is ok1? Ok1 is a boolean. After if, what is required? After if, whatever the condition you write, you may write and or not or different logical operators you use. Ultimately the final result should be it should yield the final result as true or false. It only expects after if, whatever the condition you write here, it should yield either true or false. That's what actually if wants. You can write very big condition with a lot of logical operators or other operators. It doesn't care. Ultimately what it wants is either true or false. That's what any if condition in any programming languages. OK1, that means if OK1 is true, it is nothing but it's analogous, same as above. If OK1, which is means if OK1 is true, print line num1 as num1. You are just printing num1. Maybe you would like to num1 square. Num1 square equal to, you can put just doing some mathematical operation. If OK1, that means when you are type asserting it, it returns 2. If you want, you can put only 1, but if you want to check whether this is the type that x2 has got, then you have to use these both variables. OK1 is this. That means OK1 is true. Else, that means it is false. Print line x2 is not int. This is what you can do. x2.int, which is a type assertion, it is not just a type assertion, it also returns two return values. If you want, you can also use one return value. There is no problem directly, like how we are doing in your previous example. We're just taking only one variable. But there is a provision that it also returns two values. Not only this, even the channel does, even the map does in Go. There are some areas in Go that it returns two values. Certain things in Go. Map does that. Uh, map does that. Channel does that. Even the empty interface does that. Any does that. It returns two values. Maps, you know that maps are dictionaries and other programming language. Channels are special, very special to Go. Yeah, cool. Now you are avoiding a panic. You are avoiding a panic. Go run. So x2 is not int. X2 is not int. Okay, if f2 x2 is not int, if x2 is not int, what could be x2? If you want, you can write a logic again, another logic here. I can create this one, same one. Okay, declared or not used because it is in a separate scope. So these two variables are again created. I give float 64. Okay, again I do the same thing. If OK1, I print the value, else I put it as x2 is not float 64. So x2 is neither int nor float 64. So after this, in the else part, you can also use else if. Okay, you may ask me why should I use else? You can also use else if, but I have written like this. If okay, that means yes, it is integer. Else again I check with float 64. Again okay, yeah, num1 square, num1 square. You're going to put the num1 into num1. Okay, you can put fmt dot print line or printf. I would like to put it as percentage point to f. Otherwise, it gives a very big number, and I would like to submit over here. I think something went wrong. It is going that it's not even float 64. It is saying that even it is not float 64. First it has gone this, again it is showing float 64. If f1 this, it has given the result, but I think after this it went here. So I think this statement I have to put over here. X2 is neither int nor float 64. So this is the num1 square because it is float 64. This is how, what if the any has got two variables, which is called type assertion, and then how do you assert any? Okay. A simple task I give you, what I do is I create a directory called tasks. What the task is, create a create variables. What kind of variables they are? Uh, int, uint, int 8 to int 16, sorry, int 64, and uint 8 to uint 64, room, byte, any float 32, float 64, any. Create variables of these types. Assign numbers to respective variables. That means num1 is int, which gives some number, any also gives some number, and create sum of all numbers. Oh, sorry, I want to calculate. Why it's giving error? Calculate sum of all numbers. What you have to do is calculate sum of all the numbers. Put it into a variable, something called float 64. Uh, so that means sum is something like where sum equal to float 64 equal to, yeah, maybe num1 plus num2, it should work, etc. But num1 is int, num2 is uint, num3 is uint8, and so on. This is very, very important for me. This is the task you have to do. Okay, so you understand how to do type assertion. You understand how to do uh, type casting, type assertion, how to perform a basic arithmetic operation, and etc. Okay, this is what you have to do. Okay, that thing you have to do. That's something which is very important. This is what about any.